In previous video, we have discussed about Doppler effect, that is method number 1. Now, we are going to discuss about Doppler effect method number 2, means this is the type of time period method. Means in previous video, we have discussed in case of apparent frequency and apparent wavelength. Here we are going to discuss about time. The time travel taken by the source to travel and the time taken by the observer to receive the wave. Then here the source and observer is away from at a distance of L. At a distance of L, S meet by the source and observer O meet by the observer. Observer is at rest, V naught is equal to 0. V naught means observer velocity. Then S means the source, and when the time t is equal to 0, at a time t is equal to 0, the source released one wave and the time taken to received by an observer t1 is equal to the total distance by which is moving with velocity v, actual normal velocity v, speed of a sound. So that's why L by v. This is the L by v is the formula for time. T is equal to L by v, total distance by velocity. This is the first wave. Whenever the source is at some of the distance, at a distance of L, it is released first wave and the time taken to received by an observer is t1 is equal to L by v. The t is equal to 0 is the time taken to release the wave, first wave. So that's why we are taking the t1. And after some time t is equal to t naught. After some time t naught, the wave traveled, the source traveled to the point S dash, some of the distance, that is Vs t naught. Traveled distance is Vs t naught, and after reaching the S dash, it is released another wave. It is released another wave, that is the wavelength is the total length is L minus Vs t naught, because of the total distance traveled by Vs t naught and the total distance is L. So the point distance from the S dash to the observer is L minus Vs t naught. So that's why we are writing that whenever the second wave release, means T2 is the second wave, the time taken by the second wave to received by the observer T2 is equal to the time taken to travel is T naught. The total time, what is the time I taken after the first wave is released? The time taken to travel from the S to S dash is T naught plus the time taken to received from the S dash to the O, time taken to receive the wave from the S dash to the O is means the distance from S dash to the O is L minus Vs t naught. So L minus Vs t naught by the velocity is the always it will move with the velocity of sound. So in air is v. So that's why here is that whenever by taking that, if in case of t is equal to, after taking that some distance S double dash means t is equal to 2t naught, then we can get that after third wave as released, t3 is equal to t2 means 2t naught plus L minus 2 Vs t naught by v. Like that, for n number of waves are released, whenever it is t is equal to n t naught, here is the t n minus n plus 1 wave can be released. So that's why we are writing that after traveling some of the distances, means n t naught points, means number of t naughts, number of waves are released for traveling towards an observer, number of waves are released, that is t n plus 1 means here is that one, t is equal to 2t naught. Then we can get that T3 is equal to third wave as released, so that's why n plus 1. Whenever nth wave has released, n distance has traveled, the n plus 1 wave has released. The time received by the observer is n plus 1 wave, so that's why t n plus 1 wave. So here is that n t naught plus L minus n Vs t naught by v. Here is the whenever the t n plus 1. Then we already find out that the whenever n t naught wave, n t naught times has traveled towards an observer, then n plus 1 wave has received by an observer, then n plus 1 is equal to n t naught plus L minus n Vs t naught by v. Is the whenever the time taken to receive the observer, the waves received by the observer is t n plus 1 is equal to n t naught plus L minus n Vs t naught by v. Here is that. Then now what is the time period? Means the time, total time, what is the total time has taken to received by an observer? Means the total time taken to receive the total waves, number of waves as received by the observer. What is the time has taken to receive all the waves by an observer is t is equal to, total t is equal to, here is the tn plus 1 minus the initial wave is t1, initial wave is t1. So here is that the t is equal to, the equation is nt naught plus L minus nvs t naught by v minus L by v, minus L by v. Here is that by calculating this, then wherever t naught is common, so that's why we are taking this side, and nt naught plus L by v minus nvs t naught by v minus L by v. So here is that L by v get cancelled, then we can get nt naught plus, sorry, nt naught minus nvs t naught by v. Here is that nt naught is common, so that's why we are taking that small t is equal to n of nt naught of 1 minus vs by v. Here is the total time taken to observe all the waves from the t1 to tn plus 1 waves. The total time taken to nt naught of 1 minus vs by v is the time taken by an observer to receive all the waves, the number of waves, n plus 1 waves received by an observer. Here is the total time as taken. Then the period of the wave, period of wave is capital T is equal to total time by number of waves are produced. So that's why we are taking that T is equal to n T naught of 1 minus Vs by V by n, means T means time period for a time taken to complete one wave, that means to say total time by number of waves are produced, then only we can get the time period, means period of the wave. Then n get cancelled, then we can get T is equal to T naught of 1 minus Vs by V. Here is the equation for an time period for the wave according to the Doppler effect. If we find out that after time period of the wave T is equal to T naught of 1 minus Vs by V. T is equal to T naught of 1 minus Vs by V is the equation for the time period of a wave. Then from that, but we know that nu is equal to 1 by T, means the reciprocal of time period is equal to frequency of the wave. So here is that nu is equal to 1 by T, we are substituting in the equation nu is equal to 1 by T naught of 1 minus Vs by V. Here is that 1 by T naught means nu naught is apparent frequency, 1 by T naught is equal to apparent time period. Then we can get that is equal to nu is equal to nu naught of 1 minus Vs by V inverse. We are taking that whenever it is denominator taken to the numerator, then numerator inverse we can get. So from the binomial theorem, from the mathematical expression binomial theorem, from binomial theorem, 1 plus x power n is equal to 1 plus nx. If in case of 1 minus x power n is equal to 1 minus nx we can get. So that's why from the formula of we can writing that then nu is equal to nu naught of 1 plus Vs by V. This is the equation for an apparent frequency of sound due to the relative motion. Whenever it reaches the nu is the actual frequency, nu naught is the apparent frequency. From that equation we can get that whenever the source approaching an observer, then always apparent frequency is greater than actual frequency. So here is that we can write that. So this is the equation for an apparent frequency of a wave. According to this, here just we need to get that binomial theorem, that is 1 plus x power n is equal to 1 minus 1 plus nx. From this formula you got the here the frequency is equal to reciprocal of time period. So that's why we are substituting the t is equal to t naught of 1 minus Vs by V in the equation, and we know that nu naught is equal to 1 by t naught. Just by substituting nu is equal to t is equal to t naught of 1 minus Vs by V in the equation, then 1 by t naught is equal to nu naught. then 1 minus Vs by V whenever taking to the numerator, then it will become 1 minus Vs by V inverse. From the binomial theorem 1 plus x power n is equal to 1 plus nx formula, then we are writing that nu is equal to nu naught of, it is that Vs by V is in the position of x, so that's why 1 minus of minus nx means here is that nx, n we are substituting that is either plus or minus, it doesn't mean that here is in case of minus 1, so that's why we are substituting minus into minus plus, then in the x position is n into n means 1, 1 into Vs by V is the x position. If we want to find out the whenever the away from an observer means away from an observer, we can get that the frequency is equal to nu naught of 1 minus Vs by V, because of it is in opposite direction. Vs means here is that moving towards an observer means when the source velocity is adding, the frequency is adding, but second by second the frequency is adding, so that's why we are taking this one. Whenever it is receding from an observer, then we can get the frequency will be goes on decreasing, second by second goes on decreasing, so that's why nu is equal to nu naught of 1 minus Vs by V whenever the source is moving away from an observer. In this case, this is here apparent frequency is less than actual frequency, apparent frequency is less than actual frequency whenever the source is moving away from an observer. This is method 2 for the Doppler effect, when the source is moving towards an observer and away from an observer. Thank you.